What's up everyone, Patrick here, welcome back. In this next video, what we got to do, we got to take this expression here and we have to simplify it. So notice we got x over x plus 4 over 3x, and then all of that is over x over 5x plus 20 plus 3 over x. So different ways you can go about this. What I'm personally going to do is I'm going to take the numerator and the denominator, and I'm going to work with both of them separately, and I'm going to combine them into single fractions. So then we'll have one fraction divided by another one. So first, writing out this numerator here. To make this into one fraction, we got to get a common denominator because we have two fractions that are adding. So notice we have x plus 4 and 3x. Those are different factors. So the common denominator between them would be just both of those factors multiplying. So we'll have 3x times x plus 4, like that. So what do we do here? We took the x plus 4, multiplied it by 3x to get this, so it means we have to take the top, multiply it by 3x, and then the 3x, we multiplied it by x plus 4, so we got to multiply the top by x plus 4. So what we would end up with is 3x times x is 3x squared, and then here we'll have 4 times x plus 4, and if we, let's expand it, so this would end up being 4x plus 16. Like that. And then from here, what you want to do, notice the denominator is factored. You want to factor the numerator as well. See potentially if this can simplify further. But the numerator actually doesn't factor because there's no two numbers that multiply to 48. 3 times 16 is 48. So no two numbers that multiply to 48 and add up to 4. Right? That's not going to factor further. So this here ends up being that numerator. So we're going to have 3x squared plus 4x plus 16 over 3x x plus 4, like that. And then what I'm going to do is I'm going to do the exact same thing with the denominator. So the denominator, we have what? X over 5x plus 20 plus 3 over x. Now actually the 5x plus 20, that factors, we could take out a 5 from there. So I'm just going to factor it here. At some point we're going to have to factor it. I'll just factor it at this point. So we could take out a 5 from there and we'd be left with x plus 4. And then from here, same thing. So these are two different factors, so the common denominator between them is going to be both of them multiplied. So this x I just put here in between when we multiply. So this we multiplied by x, meaning the top we have to multiply by x. And then this x here we multiplied by 5 bracket x plus 4. So this 3 we have to multiply by 5 bracket x plus 4. Like that. So x times x is x squared, and then we'll have over here when we multiply these, so the 3 and the 5, we'll have 15, the x plus 4 still in brackets, then we'll have x squared plus 15x plus 60. And that's going to be all over 5x x plus 4, like that. Yeah, it looks all good to me. Now, this x squared plus 15x plus 60, that doesn't factor. There's no two numbers that multiply to 60 and add up to 15, right? So we just leave it like that. So this here, this expression simplified to this. Like that. And so now notice, in my opinion, I feel like this is better to work with than this because now we have single fractions in the numerator and the denominator. So it's like this divided by this. So we could actually rewrite this instead. Instead of having it in this fraction format, we could take this divided by x squared plus 15x plus 60 all over 5x x plus 4 instead of writing it here. Right, and now this just becomes like dividing rational expressions like we've done before. Now from here, before we simplify, what we can do is we can get the restrictions. If they ask for restrictions, they may not. If they do, notice the denominators can't be 0, so notice these x's by themselves. That means x can't be 0. And then notice the x plus 4 can't be 0, which means x cannot equal -4. Now, because we're dividing here, you also want to get the restriction from the numerator if possible. But x squared plus 15x plus 60, that actually can't equal 0 ever for any x value. Right? Even though it doesn't factor, you want to potentially plug this into a quadratic formula to see when it can equal 0. But if you plug this into the quadratic formula, that discriminant, which is just the b squared minus 4ac, that's the expression under the square root in the quadratic formula. This is going to be negative because we're going to have 15 squared minus 4 times 1 times 60, which would be 225 minus 240. Right, so that discriminant is going to be negative 15, can't square root a negative number. Right, so there's no x values for this quadratic that's going to make it equal to 0, hence there's no restrictions that we can get from this numerator over here. Right, so those are the two restrictions. X can't be 0, x can't be -4. And then from here we just simplify. So because we're dividing, what we do is we flip this and multiply. That. And then notice the x plus 4's cancel out. Notice the x's cancel out. And then as we mentioned, this doesn't factor, and then 5 over 3, those don't simplify. If this was maybe like a 6 over here, then we could cross out the 3 and the 6 and put a 2 there. But the 5 over 3 doesn't simplify. So what we would end up with is just, yeah, let me write it over here. So this would be the final answer. It'll be 5 bracket this quadratic, 5 times this, all over 3 times that quadratic. And that's the final answer. This doesn't simplify any further. So that's what it simplifies to. And then those are the restrictions. If this is a multiple choice test, this may be expanded, like this 5. This numerator here may be 15x squared plus 20x plus 80. And then this denominator might be 3x squared plus 45x plus 180. But if they ask you if this is like a short answer problem, then this is the proper simplified format. You always want to make sure you factor everything to see if stuff further cancels out. So you would take out the 5, take out the 3, but then the 5 over 3 doesn't simplify. Right? So that's the final answer. Those are the restrictions.